of our operating system class, we told that operating system is called as a resource manager. Okay, so there are different types of resources in the operating system and in the system, like memory, CPU, I/O devices, registers, CPU cycle. How properly these resources will be used or utilized for execution of the processes. So CPU is one of such resource. So here the operating system works as a resource manager. How operating system will use the available CPU cycle of your system to execute different programs that you are going to submit. You may submit different programs concurrently. There can be n number of programs that you can submit. Now, how efficiently this program will be scheduled to the CPU such that their execution time will be faster, because we are always looking for faster device. We always look for faster device. That is our objective. So, we want that faster machine, high speed machine. So, what is high speed machine or faster machines? Basically, जिसमें in the machine where I submit the task and I will expect the task will be executed very fast. That is my objective. So we are always looking for faster device, faster machine, faster execution. Okay. Here, operating systems works as CPU scheduler. How this set of programs that you are going to submit will be scheduled in the CPU such that their total execution time will be minimized. Just like we have class routine schedule, in the same way we need to make some kind of scheduling algorithm. In the class routine schedule, there are different subjects. Each subject has a different number of different syllabus. Theory subjects have some limitations, some requirement. Lab subjects has different limitations and requirement. Teachers has some limitation and requirement, as well as the availability of the classroom, as well as the lab classes. Okay, so depending on the available resources, how efficiently these subjects will be scheduled in a routine such that all the requirement of all the subjects will be fulfilled and the syllabus will be completed within a in a scheduled time. Maybe amount of syllabus that needs to be completed within your mid-sem, then that amount of syllabus needs to be completed before the final sem. So these are different requirement of different subjects. So that needs to be fulfilled by the class routine schedule. That is the objective. So if you see, we are always today we are not just happy by submitting a single program at a time. Rather, we want that number of programs will be submitted to your system at the same time. This is one requirement. That means we want to submit number of programs at a time. So we want concurrent execution, parallel executions, or multi-programming environment. That means number of programs can be executed simultaneously. That we have the knowledge how number of programs are executed simultaneously. So in one side you have degree of multi-programming. On the other side, there is not only one single CPU, rather there can be number of CPU in your system. There may be dual core, maybe quad core, like that. Okay, so in one side you have CPUs, maybe 4 CPUs, maybe 8 CPUs, maybe 16 CPUs. On the other hand, you are submitting number of processes for executions. So how these processes will be scheduled in those CPUs such that the total execution time will be minimized. So basic concept is maximum CPU utilization obtained with multi-programming. Number of programs you are submitting at the same time. Second, if you see the execution pattern of a process, it composed of CPU burst and IO burst. What is that burst? Suppose you have written a program. You have written a program. That program composed of number of instructions. That program composed of number of instructions. If you see in a very micro level, that you will find that some of the instructions will be executed by the CPU. Some of the instruction needs some IO. Again CPU, again IO, again CPU, again IO. So it's a kind of alternative sequence of CPU and IO, CPU and IO, CPU and IO. This is called burst. This is called burst. So it is a combination of alternate sequence of CPU burst and IO burst, CPU burst and IO burst, CPU burst and IO burst. So when a process is in the CPU burst, it will use the CPU cycle. When it is in the IO burst, that time this execution, this time this particular process will be in a IO operation and the CPU will be free, that can be given to some other process. Again it will be looking for CPU. Again it will come to IO. So this time again it will be given to some other process. So a process execution of a process is a combination of CPU burst and IO burst. CPU burst and IO burst is a combination of CPU burst and IO burst. CPU burst, then IO burst. CPU burst, IO burst. CPU burst, IO burst. So when it is a CPU burst, it will look for some kind of IO operations. That means input output. Maybe it is looking for some input from the keyboard. Maybe it is looking for some input from the mouse. Maybe it wants to give some kind of output to the monitor. Or it needs some kind of printer. Or it may be writing some output values to the file. Or it may be taking some input from a existing file. So this is. And these burst values are very, very small in length. So if you see a typical program, it looks like this. This is the frequency and the burst duration, CPU burst duration in a typical program. These are order of millisecond. So you can understand how small it is. Okay, so if you see around 155 numbers of CPU burst, which is of duration this. That means 150 CPU bursts are of duration maybe 3 millisecond. There are some which is of 8 millisecond. Then your 6 kind of like this. Okay, so my idea is a combination of CPU burst and IO burst, and this is very small in length. So when one process is going for IO burst, that time other process may be used by the CPU for execution. So what is CPU scheduler? If you remember, we have discussed this thing. This is my ready queue. Run state. Wait. Then again ready. Terminate. So CPU scheduling decision may take place when a process switches from running state to wait state and running state to wait state, or even running state to ready state also. So ready state to running state to ready state, and switches from waiting to ready and terminates. So this decision is being taken by the CPU scheduler. So it basically chooses which process from the head of the ready queue will be chosen to send to the CPU for execution. So you may submit 6, 7, 10 program at the same time for execution. So all the programs are ready in the ready queue. Now which process will be taken from the head of the ready queue and will be sent to the running state? That decision is taken in this particular scheduler. What is the objective of, or what is the criteria to choose a scheduling algorithm? The first criteria is CPU utilization. It says keep the CPU as busy as possible. That means we don't want to keep the CPU idle. We don't want the CPU to be idle. So we want to increase our CPU utilization. We want to increase the CPU utilization. Throughput. It says the number of processes that completes their execution per unit time. What should be our objective? Minimize or maximize? Maximize. So we always want that number of processes that will be completed by the CPU will be maximum per unit time. That means again we are looking for faster device. Turnaround time. Amount of time to execute a particular process. That means you submit a process to the system and it gets executed. So this duration is called the turnaround time. The time at which you submit and the time at which the process gets executed, that terminates. So this duration is called the turnaround time. So amount of time to execute a particular process. So again, what do you want? Maximization or minimization? Minimization. Waiting time. Amount of time a process has been waiting in the ready queue. You submit a process, apart from the execution time, it is in the waiting queue or in the ready queue. Sorry, it is in the ready queue. So that is your waiting time. That means it has all the thing to be executed, but it is not getting the CPU cycle. And that's why it is kept in the ready queue. So this time is called the ready or waiting time. So what will be your objective time, to minimize or maximize?
Minimize, sir.
So your objective will be to minimize the response time. Amount of time it takes when a request has been submitted until the first response is produced. Response and output are not the same. Suppose you are 107 student today in the class. I asked a question, maybe what is context switch? I know many of you can definitely give the answer. So some of you raised your hand. This is called the response time. The time at which I asked the question and the time at which I got the first response, in the sense by putting the hand that okay, I can give the answer. This is called response time. And output, when you give the entire answer. So response time, amount of time it takes when a request was submitted until the first response is produced, not the output. Mind it, not the output. I am waiting only for the first response to receive. So in this chapter, we will be discussing number of algorithms for CPU scheduling. Now, you may have something in your mind to have some better algorithm for CPU scheduling. So how do you check? So these are some of the evaluation criteria that how better or how, I mean, to compare your algorithm with the other algorithm through this criteria, that how much your algorithm is capable of utilizing the CPU, how much time it takes for throughput, or turnaround time, or waiting time, response time. So these are the criteria through which you can evaluate your algorithm. Maximization CPU utilization, maximization throughput, minimization turnaround time, minimization waiting time, minimization response time. So these are in computer science language, this is called the metric to evaluate the CPU scheduling algorithm. Just like the CGPA is a metric, CGPA is a metric to evaluate who is the best student and who is the average student in your batch, who is the topper in your batch. So CGPA is one of the metric to evaluate the merit of the student. CGPA is a metric to evaluate the merit of the student. In the same way, these are the metric. CPU utilization, maximum throughput, turnaround time, waiting time, response time. These are the metric to evaluate the CPU scheduling algorithm. Understand? Follow. Any issue with this?
Sir, is it like one of those metrics have more importance than the other?
It depends on in what it depends on in the situation that what type of task you are submitting. Okay, so there are some time-bound tasks like real-time tasks. That means your task must be completed within a fixed time. Otherwise, its performance will be degraded or it is of no use. Okay, so depending on that, you can choose. Otherwise, there is no as such difference. I mean, difference in the sense that one is better than other, or I mean, you cannot compare the two metric unless you have the task specific requirement is there. So one is real-time task, another is non-real-time task, or sometimes you can call batch processing task. Okay, so depending on the type of task you are giving the system. In general, you cannot differentiate that which metric is better or which criteria is better or which criteria is best.
So, sir, you mentioned the two types of tasks, that real time and the task that can wait. Okay. So, if there are a lot of real time tasks thrown at a CPU one after the another, is it possible that the waiting time of that old task is increasing? and then it's like just waiting there, not being processed.
See, real-time tasks are, or real-time system are those systems where the task comes for execution with some deadline. With some deadline. Okay. Now, within that deadline, this deadline also can be of two types. It can be soft real time, it can be hard real time. If it is a hard real time, then if the task is not completed within that deadline, then there can be some catastrophic happens, maybe some life risk, some monetary loss. The other one is soft real time. If the task is not completed within that deadline, then the output quality will be degraded. Okay, so it is another side of the discussion. I will not go into that detail right now. If you want, I can give you material, or I can have other lecture as well. Okay, but in your normal syllabus, you don't have a real-time system. So real-time operating system is another branch of operating system, you can say, like rocket system or flight monitoring or flight control. ठीक है ईशान?
Sir, I was just asking ki, okay, if that real-time operating system is used in rocket, so it has to go through the continuous monitoring of, let's say, gimbal, the
Yes.
throttle gimbal. Okay,
Yes.
so is it possible that the process or the CPU is so busy controlling the real-time operations that it just increases the waiting time of normal
Not
operations to extended
yes,
limits?
yes. If you don't have that much of CPU cycle, it can happen. So you, as a designer, you need to take care of that thing, of course, of course.
That's what I was asking, sir.
Yes. So let us take the first example of our first scheduling algorithm. Okay, so the basic fundamental algorithm for CPU scheduling is first come first serve. So what it says, the order in which the processes are coming in the system, in the same order it will be sent to the CPU for execution. For example, process P1 comes first with a burst time of 24 unit. That means its next burst time is of 24 second, or maybe millisecond. Let us millisecond. P2, its requirement is 3 millisecond. P3, its requirement is 3 millisecond. Now, as we are going FCFS, that says the order in which they are coming in the same order it will be executed, or it will be sent to the CPU for execution. That means the order they have arrived in the ready queue, in the same order they will be sent to the running state. Clear? That is FCFS. First come, first serve. So this particular diagram is called Gantt chart. How Gantt chart is prepared? It starts with 0. Process P0 come first. It requires a burst time of 24 milliseconds. So P1 will be in the CPU for 24 milliseconds. So keep P1 for 24 milliseconds. Clear? So after 24 milliseconds, P1 will be completed, or means the burst time of requirement of P1 will be completed. So the next process is P2. Keep P2. How much time? Its requirement is 3. So keep it for 3 milliseconds. So it comes at 24 after P1. So it will be here 25, 26, 27. So P2 gets completed. Then P3. Again, P3 will be there for 3 milliseconds. So 28, 29, 30. So this is my P1, then P2, then P3. Now, is the Gantt chart clear?
Yes, sir.
Yes, sir.
হ্যাঁ প্রযোজক তোমার নেটওয়ার্ক ঠিক করো ভাই, শোনা যাচ্ছে না তোমার কথা।
Sir, what is the difference between burst time and turnaround time?
Yeah, I'm coming. বলো, first tell me whether this Gantt chart is clear or not. Is the Gantt chart clear? I mean, this diagram is clear?
Yes, sir. Yes,
Yes,
sir.
sir.
Okay,
Yes, sir.
good. Now, P0 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 comes here at, so we assume that all the processes come in the system at the same time. We assume that all P0, P1, P2, P3 come in the ready queue at the same time. So how much time P1 was waiting? Can anybody say? How much time P1 was waiting before it was sent?
Zero.
Zero. Because the moment P1 come in the system, immediately it has been sent to the CPU for execution. So the waiting time for P1 is 0. What about P2?
So 24.
24, because P2 also come at the same time when P1 come in the system. But P2 has to wait to get the CPU cycle till P1 gets completed. So P2 has to wait for 24 milliseconds. So the waiting time of P2 is
24.
24. What about the P3?
27.
It has to wait
27.
24 plus 3. 24 plus 3, because P3 also come at the same time when P1 and P2 come in the system. So P3 has to wait for 24 plus 3, that is 24. So what is the total waiting time? 0 plus 24 plus 27. What is the average waiting time? Divided by 3 process. बोलो क्षितिज, जो क्वेश्चन किया था क्लियर हुआ? क्षितिज ना और को क्या कर ले क्वेश्चन टा?
Yes, sir. I was asking the difference between burst time and turnaround time.
Burst time? Okay, burst time and turnaround time. I'll be coming with an example. Better I should come with an example. Let me see whether this example is there or not.
Okay, sir.
I will definitely come to you. Okay, don't worry about that. First tell me,
Sir.
bolo.
Sir, burst time and turnaround time will be same if they are coming at t equals to 0. We can say that.
Yes, right, Saurabh. Right. I will come to with an example. Please wait for some time. So is this example clear?
Yes, sir.
I have another book that I left in my department, which will give the example. Okay. Now you see, suppose the processes arrive in this order. Suppose the processes arrive in this order: P2, P3, P1, or you are sending P2 first, then P3 first, second, then P1. Not arrive, rather you are sending to the CPU for first P2, then P3, then P1. So as P2 3, P3 3, 24. So P2, keep the P2 for 3 millisecond. Then put P3 for another 3 millisecond. Then P1 for 24. So waiting time, you see, total waiting time is 6 plus 0 plus 3, and average waiting time becomes 3. So much better than the previous case. So both the cases you are using the same FCFS. For both the cases, you are using FCFS. The order in which they are coming in the same order you are sending. But you see, just you change the order. This is called convoy effects. Convoy effect, short process behind the long process. Short processes, these are the short process in comparison with this. So short processes behind the long process. That's why this value is much higher. This value is much higher than of this one. This is called convoy effect. Have you seen the convoy? Convoy of prime minister, convoy of minister, or convoy of a big political party?
Yes, sir.
So this is called convoy effect.
Sir, short process behind long process, as in the short process has to be earlier than the long process.
Many, if your algorithm puts the short process behind the long process, then the short process has to wait for a long, and that's why the total waiting time will be much higher. As a result, the average waiting time will also be higher. That is called convoy effect. বোঝা গেছে?
Yes, sir.
Next, I will be coming with another example, shortest job first. The job which has the short burst time will be scheduled first. Just see this example, then I think it will be clear with all of you. Whatever confusion you have regarding burst time, then arrival time, because this example will contain both the arrival time as well as burst time. So let us assume there are, for the time being, you don't consider this one. I will be discussing this later. Suppose there are 4 processes, P1, P2, P3, P4. Arrival time. That means in this position it has arrived to the system. 0th time, the second position, in 4th position, in the 5th position. So arrival time. Their associated burst time is 7 millisecond, 4 millisecond, 1 millisecond, 4 millisecond. Let us draw the Gantt chart. Gantt chartটা ভালো করে দেখো. The way I am drawing. At the 0th time, what are the processes in the system? Let me tell me.
P1. Yes.
There is only one process, P1. Any confusion? At 0th time, there is only one process in the system, that is P1. So you don't have any choice rather than sending of P1. ঠিক আছে? Kidis?
Yes, sir.
So place P1 in the CPU. कितना तक रहेगा P1? 7.
Sir, seconds.
7. So once 7th second is completed, 7 millisecond is completed, P1 is no more in the ready queue. P1 is no more in the ready queue. What are the other processes by 7th position? What are the other processes in the ready queue?
P2, P3 and P4.
Okay. P2, yeah, P2, P3 and P4. So which one you need to choose? Whose burst time is? Whose burst time is the shortest one? So choose the burst time whose burst time is shortest one. P3.
P3.
How much time it will be there?
1 millisecond.
So after 8 seconds, it will be completed. ठीक है? Now you have two processes, P2 and P4. Both are having the same burst time. So this is a tie. Which one to choose? Because you are going for shortest job first. The simplest approach to break the tie, you follow FCFS among the tie processes. So P2 and P4 both are having the same burst time. Choose one which has come to the system first. So which one will be?
P2, sir.
So keep the P2 there. For how much time?
4 millisecond.
P2 भी complete हो गया. Sorry, P2 भी complete हो गया. Next, you have only one process, so there is no choice. ठीक है? Any doubt up to this?
Sir, if a process P5 had come at 8th millisecond with a burst time of let's say 2 millisecond, then would it come before P2?
Yes, it would come before P2.
Okay, sir.
Bolo, is this clear up to this?
Yes, sir.
Okay. So I will ask you to draw the diagram, or better make a table like this. So this is already there. You make another table. Finish time. Finish time. Then your turn around time and waiting time. You make 3 more columns. Follow. What is the finish time for P1?
7, sir.
7.
What is the finish time for P2?
12, sir.
8. 8. Sorry, 12.
For P4?
So 16, sir.
ঠিক আছে?
16.
What is the turn around time?
7.
7.
What about this?
10
10.
seconds. 10 milliseconds.
10 milliseconds, right. What about this? P3?
4 milliseconds.
4.
For this?
11.
It's 11.
Any confusion with anyone?
Sir, turnaround time টা বুঝলাম না স্যার।
Turnaround time টা মানে হচ্ছে, বলো anybody? আদিত্য বলো, what is turnaround?
First,
Sir, the time it takes to complete its process.
আর একটু ভালো করে বল।
Difference between the finish time and arrival time. I mean, it will take some time in the ready queue also, na. So it is
So
more
that means it is
turnaround.
it is the total time. It is the total time is in the system. Maybe it is in the waiting in the ready queue or in the execution state. In total, we will be calculated as turnaround time. So finish time minus arrival time. That will give you the turnaround time. Then what? Hey, বুঝলে প্রযুক্ত?
sir. Sir.
Then what about the waiting time?
0.
Turnaround time.
কোথায় বলো,
Minus arrival time.
how do you calculate waiting time?
Turnaround minus burst.
Yes, turnaround minus base. Very good, Vishwajit. So this will be. বলো Vishwajit, বলো।
7. 0. 0.
Zero.
Oh, sorry, sir. Sorry.
এটা
6.
6.
এটা
3. 7. 3.
So total turnaround time and average turnaround time. Average turnaround time.
Sir, waiting time is turnaround time minus
burst time. The time it has been spent in the CPU.
okay, sir.
So average turnaround time, total turnaround time divided by 4. Average waiting time, total waiting time divided by 4. বোঝা গেছে? হ্যালো,
Yes, sir.
Yes, sir.
Kitish, तुम्हारा जो क्वेश्चन था, is it clear?
Yes, sir. Clear.
मैंने बोला था just you give me some time, I will come with an example. Follow. Anyone has any questions regarding the confusion about burst time and क्या बोला था turnaround time? I think some people have the confusion about the turnaround time and burst time.
Sir, can you repeat the definition of turnaround time?
Turnaround time means the time it has arrived for execution, then the time it has completed its execution. So it arrived in this time, it gets completed at this time. So turnaround time is 12 minus 2. How much time it has spent in the system? How much time it has spent in the system, that is your turnaround time. At burst time, the time it requires the CPU for execution. So obviously, turnaround time minus the burst time, that will give you waiting time. হলো, ক্লিয়ার হলো? কি জিজ্ঞেস করলাম এই কোশ্চেনটা? ছবি করে লাগাচ্ছ না কেন? ইয়ার মুখের ছবি করে লাগাও, তাহলে তো বোঝা যায় কোন ছেলেটা কি। নামগুলো তো সবার মনে রাখা যায় না। এই যে এরা লাগিয়েছে কি সুন্দর, প্রযুক্ত লাগিয়েছে, অর্ক লাগিয়েছে, কৃষ্টিস, আদিত্য, মোটামুটি ঠিক আছে। ईशान समझ में आया?
Yes, sir.
এই সৌরভ ঠিক আছে?
Yes, sir.
কোনো কনফিউশন নেই তো?
No, sir.
ঠিক আছে। Now listen carefully. Shortest of first is a scheduling algorithm. বোঝো তো, একটু মাইকটা করো, দাও, মিউট করো। Shortest of first is a scheduling algorithm which choose the job whose burst time is the minimum one. Now, this can be of two type. The shortest of first type of algorithm, shortest of first algorithm can be of two type. It can be preemptive type. It can be non-preemptive type. Preemptive means when a running process is interrupted due to some reason, then it is called preemptive scheduling. Preempt means before complete execution it has been preempted, stopped कर दिया गया. Non-preemptive means once it is scheduled in the CPU for execution, it will be completed, then only it will release the CPU. So there are two type of algorithm. One is called preemptive type, another is non-preemptive type. Preemptive type means one, it is in the, if a running process is forcibly stopped, you are staying with your second year or third year senior, you will assume that you are in a first year student. You are sharing hostel with your senior, third year or second year. You are in the mess to take your ID dinner. While taking dinner, taking the food from the queue, you have taken some food and you suddenly saw that one of your senior is waiting behind you. So immediately you will leave the place and you allow your senior to take the food. This is called preemption. Before completing of taking your food, you allow your senior to take his food. This is called preemption. The other one is non-preemption. Now, if you see this algorithm, we discuss the non-preemptive nature of SJF. Once a process is given to the CPU, it is in the CPU till its execution is completed. Similarly, once P3 is in the CPU, it is in the CPU till it gets executed. P2 is in the CPU, it will be in the CPU till it gets executed. Like this way. The other one can be while P1 is in the execution state, a process arrives in the system whose burst time is the required burst time of P1 से कम है. If the burst time requirement of P2 is less than the remaining burst time requirement of the running process, then the running process will be preempted and the new process will take charge of the CPU. And the running process will be sent to the ready queue. Follow. Conceptually, is this idea clear? Then I will come with an example.
Yes, sir.
What about the other people?
Yes,
Clear,
clear.
sir.
Yes, sir.
हाँ कि आदित्य क्या बोला?
Yes, sir. Yes, sir.
Yeah. Can you try by yourself? Can you try the same example by yourself only?
Okay, sir.
Try it. अगर नहीं होता तो I am there. Of course I will do it. ঠিক আছে? ও তোমরা করো কি হচ্ছে? Convert this example by shortest job first with a preemptive type. ঠিক আছে? করো তো? Then show me.
Sir, but these algorithms, do they follow the priority? Current executing program will be halted and
Yeah. Priority based algorithm is there that we will be discussing. Maybe today आज नहीं होगा, next class में I will discuss. There are some algorithm which is priority type. ठीक है? So priority में भी preemption non preemption में आ जाएगा. When we will be considering the non preemptive.
okay, sir.
I will discuss in the next class. आज time नहीं होगा. So please do it by yourself. I want to see whether the concept is clear with you or not. ठीक है? I want to see it from you.
And sir,
हाँ बोलो.
sir, I was going through the Galvin slides, sir, but actually it's difficult to refer to them, sir, because they are edition of 2013 and this is 2005, sir. Is there any way you could send the zip file of the 2005 slides, sir?
আমার কাছে যেগুলো আছে আমি পাঠিয়ে দেবো. No problem.
হ্যাঁ স্যার বিকজ 2013 একটা খুব ডিফারেন্ট স্যার, মানে অনেকটা কোড বেস স্যার রাদার দ্যান থিওরির পোর্শনটা স্যার।
আমার কাছে যে স্লাইড গুলো আছে আমার পুরোটাই বাঞ্চ করা আছে একসঙ্গে, ঠিক আছে, মানে সব চ্যাপ্টার ধরে I will zip it and send you, don't worry.
হ্যাঁ স্যার, থ্যাংক ইউ স্যার।
ঠিক আছে, আজকে পাঠিয়ে দেবো, কালকে আমি পাঠিয়ে দেবো কলেজে, don't worry about that. Even you can also get it download from site. I will send it, don't worry. জ্ঞান চারটা করো, জ্ঞান চারটা করে আমাকে একটু দেখাও কেউ একজন।
স্যার বলবো আপনাকে জ্ঞান চার্টটা যেটা করেছি।
ছবি তুলে পাঠালে তো ভালো হয়, নাহলে
ছবি তুলে স্যার কোথায় পাঠাবো স্যার?
ওই এখানেই পাঠাও না, এই যে মেসেজে পাঠানো যায় তো মনে হয়।
ও
যদি হয় আর নইলে তাহলে আমি করছি, মুখে বলে তো বুঝতে পারবো না। দেখি তাহলে দু একজন করুক আর একটু, তারপর আমি করবো, তোমরা মিলিয়ে নিও। কই অর্ক?
স্যার ছবি পাঠাতে ইস্যু হচ্ছে, আমার আসলে ইন্টারনেটটা স্যার একটু উইক, মানে আনস্টেবল হয়ে গেছে হঠাৎ।
দেখি দাঁড়াও, বাকিরা করুক। হোয়াটসঅ্যাপে পাঠাতে পারো, কিন্তু আবার ঝামেলা, মোবাইলটা এদিকে রয়েছে, রেখে এসছে। What about the other people?
করছি স্যার।
হ্যাঁ, বাকিরা চুপচাপ থাকে কেন? কয়েকজন ছাড়া কথা বলে না। কে আবার ফোন করে? কে ফোন করলে কি?
Yes, sir. Done, sir. Yes, sir.
হ্যাঁ দেখো, আমি ভেরি ব্রিফ আমি দেখানোর চেষ্টা করছি, তোমরা দেখি যদি বুঝতে পেরে যাও। Try to follow me, huh? So at the 0th time, there is only one process in the system, that is P1. ঠিক আছে? After 2 seconds, P2 arrive. So after 2 seconds, when P2 arrive, what is the left out time of P1?
5 seconds.
So
5
it is of
seconds.
5 and it is 4. So which one will be given preference?
P2 sir.
So allow P2 to execute. Clear? Jago, any doubt? So this is preemption. P2 up to 2 seconds cholar por, that is the 4th second, there are two process. P3 also arrive, whose requirement is 1, and by that time its requirement is only 2. So which one will you allow, P2 or P3?
P3.
P3 will be there for 1, that is 5, and P3 will be no more existence. When P3 completes, there are 3 process, P1, P2, P3, P4. किसका burst time कम है?
The P2.
So allow P2 for execution. How much time it will be there?
2.
7.
का खत्म हो गया. Next, P1 and P4. Which one has the
P4.
less?
P4.
How much time it will be there?
4 seconds.
7 plus 4, 11. Next. Clear?
Yes, sir.
Any doubt with this? Now, can you complete the table? Like finish time, then turnaround time, average turnaround time, waiting time, average waiting time. Can you complete the table?
Yes, sir.
Yes,
Yes.
sir.
চটপট করে ফেলো. I have another meeting from 5:15. একটু তাড়াতাড়ি করে ফেলো. Just in the same way as I have shown you the table, in the same way you will draw the table with this Gantt chart, and you will get the result. So my intention is to discuss the preemptive version and the non-preemptive version for both shortest job first. বলো কত হলো?
Sir, 16, 7, 5, 11. Finish time.
আচ্ছা, দেখো সবার তাই এসছে।
Yes, sir. 16, 7, 5.
হ্যাঁ, তাহলে টার্ন অ্যারাউন্ড টাইম বের করে নাও,
16, 5, 1, 6.
and then waiting time, average waiting time.
9102, sir. Waiting time.
ঠিক. So any confusion with the preemptive and non-preemptive scheduling? দেখো if you have any confusion I can discuss further. क्षितिज समझ में आया?
Yes, sir.
কপুরি,
Yes, sir.
বিশ্বজিৎ ঘোষ,
Yes.
দেখো কোনো ডাউট তো নেই, কোনো কনফিউশন?
No, sir.
What about the other people? Sinjan Chakraborty. Sinjan Chakraborty. Sushant Soren.
Yes, sir.
समझ में आया?
Yes, sir. Done.
সুদীপন দত্ত। সুদীপন
Yes, sir.
দত্ত বুঝতে পেরেছো?
হ্যাঁ স্যার।
ওকে, শর্ট নেবো পাল।
Yes, sir.
বুঝতে পেরেছো পুরো? কোনো
Yes,
কনফিউশন?
sir. No, sir.
ঠিক আছে তাহলে, ঠিক আছে। So Kshitiz, in the both the cases, I mean, when we go for priority based scheduling, there also we can find this preemptive and non-preemptive. Okay,
Okay.
that will be discussed in the next class. First, we will discuss the in general priority based scheduling. Then we will be going to the both the version of preemptive version and non-preemptive version of priority based scheduling algorithm. ঠিক আছে?
Okay.
চলো তাহলে আজকের মতো।
Thank you.